Okay, so let me give you a couple of hints and suggestions that might help you get started on problem 52. So the first thing let's do is collect some of the information that they're giving us and try to figure out what we need to do to answer each of the parts of the question. So line L, they've given it to us in standard form. And my first suggestion to you is that you're probably going to want to convert into slope-intercept form, so y equals mx plus b, that form, which basically just means solve for y. Okay, so that's going to help you get started there. And then for part A, it says write the equation of the line M through a point P that's perpendicular to L. So they've asked us to do a lot of things there. So let's break it up. So line M is going to be a new line. We're not sure what its equation is. However, you're familiar with how to write the equation of a line. What we need to know to write the equation of a line is, if we want to write slope-intercept form, we would write y equals mx plus b. Which means we need to know the slope for line M and the intercept for line M. Now, they gave us some information. They told us line M is perpendicular to L. So that's our next little bit that we need to remember. Let's say that I have a line that is y equals 3x plus 5. If I have another line that's perpendicular to the first one, then it will have the negative reciprocal for its slope. And then its b could be whatever. So for two lines to be perpendicular, then the perpendicular slope is equal to the opposite of the reciprocal of the first line's slope. Okay, so that's a fact that we can use. If we solved line L for y and got it into slope-intercept form, then we're going to know what the slope is for line L based on A, B, and C. In this problem, we're not really dealing with numbers, so we're just going to have these letters A, B, and C that represent any number. So if I solve for y for line L, then I'm going to get whatever that slope is in terms of A, B, and C, and then I can use that to find the perpendicular slope, which would be the opposite reciprocal. I also need a point for the line to pass through, and they tell us that that point is point P. Now point P is at AB, and so again, we don't have specific numbers, just a general variable A and B to represent the numbers. So in this case, we could do this two ways. We could write this in slope-intercept form, and you would want to think back to, well, how did I create the equation of a line when I was given just the slope and a point? And there was a technique for that, for doing slope-intercept form, but there was also a technique for doing that with something called point slope forms. You had something like this, where you were given a point, x1, y1, and a slope, and then you were able to use that to write the equation of a line. So you could do either one of those to create the equation of line M. Now, part B says find the coordinates of the point Q in which M and L intersect. Now, for that, let's imagine that line L looks something like this, and line M looks something like this. They're perpendicular to each other. At some point, they're saying at some point Q, they intersect each other. And remember, M passed through some point P, right? So it's kind of a general sketch here. If both lines pass through the point Q, then it must be true that there's a place where they have the same value for x and y. One way that you could solve for this is if you had line L, let's say L equals M x plus whatever its intercept is, and then you had line M, and it has whatever its slope was. We said the perpendicular slope, x plus, and then I'm going to give this a different letter, so let's call this D. If they intersect each other, then these two values should be the same. The x and the y values should be the same. So you could actually set these two equations equal to each other and solve for x to see what the x and y values should be. Once you get done with that, you would go on to C, and C is you're just using the distance formula. So you would literally just use the values that you've gotten for P and Q, use the distance formula. Now, I will warn you that the answer doesn't simplify. It's really part of this problem is a test to see how careful you can be in manipulating symbols and variables. So it's don't get scared if it doesn't simplify down into something neat. Just be real careful and meticulous, and you should be fine.